I'm John Frisby of youthtutors.com, and I'm going to run through the circle theorems practice question, part 4 for you. Please do the question before you watch the video, unless you're totally stuck, but it'll help you to try and deal with the question first and then look at my version of how to do it. I'm going to approach this from the point of view, let's just see if we can work out what we need to know from this diagram. Clearly we need to know these three angles, x, y and z, but let's just look at what we know and see what angles we can find. The first thing is we're given this angle here. This is a very common question for GCSE maths, is they use this particular theorem. You may well have learned 8 circle theorems or more, but the one that I would say comes up most often is the alternate segment theorem, and I'll say it again, I've said it in other videos, and it is that the angle between a chord, in this case DC, and a tangent, in this case CF, this angle here at 40 degrees is equal to an angle subtended at the circumference, in other words hung at the circumference, but based on the same arc. So this angle Z would be 40 degrees as well. Now I'm going to repeat that for you because nearly everyone finds that quite tricky. I'll say it again. The angle between the chord, in this case CD, and the tangent CF, that's being 40 degrees, is equal to the angle based on the same chord subtending an angle at the circumference based on that chord CD. So in this case, and it's in the alternate segment, this is the first segment of the circle. The alternate segment is the other side of the circle on the other side of CD. So all of this would be the alternate segment. Excuse me. So we know that Z is going to be 40 degrees. Another theorem that you will have learnt is that the angle subtended at the centre is twice the angle subtended at the circumference based on the same arc or chord. And we know that BOD is a diameter, so O is the centre of the circle. And we have here the angle X is at the centre and based on the same chord as the angle X. The angle X is based on CD. Z, actually did I say the same? I should have, it's not the same. The angle at the centre is twice the angle at the circumference. So angle X here will be twice angle Z. And so that will be 80 degrees, and I'll repeat it. The angle at the centre is twice the angle at the circumference if they're based on the same arc, and in this case it's CD. So we know X is 80 degrees. Now, how would we get the angle Y? Well, I'm not really going to use a circle theorem for it because you've got to use your common sense as well for these. And we can see that if O is the centre of the circle, then OD and OC are radii. They're both a radius of the circle, which means that this angle here and Y will be equal to each other, and they will be two of the angles in the triangle OCD, and so if they're equal and they complete the triangle OCD, then these two must add up to 100, and so angle Y and this angle here will both equal 50 degrees because it's an isosceles triangle. Right, I hope that's nice and clear for you. That's the second solutions video for circle theorems. run it through again, do the blank question again if you need to, but these are theorems that are very likely to come up in the exam. And I hope that has helped you.